Hello and welcome. My name is Vishwanath M. In this video, let us try to learn and understand this data structures laboratory program on stacks. According to the VTU syllabus, this is program number 3. I strongly recommend students to have the basic understanding of C programming language before learning the lab programs. Without further ado, let us dive into the program. In this program, we are demonstrating the data structure stack and all the basic operations. Along with that, we have a function which is used to check whether a number is a palindrome or not. Now, what you see here, an image, is the very common or most used representation of stack. Stack is called a last in first out data structure, hence the name LIFO data structure. So as easily noticeable, an item is pushed and the last item to be pushed is the first item to be popped or the first item to be removed, hence the name LIFO. It is different in queues where it is called FIFO, that is first to enter the queue will be the first to exit the queue, and that is easily understandable. So in this data structure, it is last in, first out. So and top is a very common variable used to identify our current location or in the stack. And even in this program, we are using the top, and hence this image proves to be of value. Now, having a good understanding of C is required to understand any program for that matter, and it is recommended that one has to refer various resources available online or offline to have a good grip of C and then understand the programs. Let us dive into the program now. Hash include stdio.h. So these are header files that are included in most programs. Stdio is standard input output header file, and this is essential in any program which is using standard input output operations like printf, for example. Standard library is again a header file which is used for various functions like exit in this case, and for various other reasons. Standard library header file is commonly used in most C programs. Define is a preprocessor directive, and it is used to create constant. The constant could be functions or it could be variables, and in this case we are creating a variable called max, and the value of the variable is 5 in this case. So the understanding is we are creating a stack with maximum elements to be 5, and for that reason even this image is proving a lot of value. Now I won't get into the details or the syntax of creating a function, creating a array, creating a variable for that matter. All this has to be understood before trying to write a program in C. So having this assumption laid out upfront, let us understand the program now. What we see here are global variables of type integer. We are creating an array of the size max. So what this essentially means is we are creating a array of integers of size 5. Int top is a variable. As I said, top is a very common variable used to identify the location or the current location in the stack, and it is initialized to -1 in the beginning. We will understand why it is so as we go further in the program. Now there are a set of functions, each function used to implement a certain functionality of stack. If we are referring to the syllabus or if you are referring to the question will normally be in such a way that you are asked to create a stack and implement functions like push, pop, display the contents of the stack, and check if the number is palindrome or not, and so on and so forth. So here are various functions laid out. So this is a very common way of programming. It is called functional programming, where you create functions or a set of lines for that particular purpose. So that is the basic understanding or the basic introduction. Void is the data type or the return type of this function. That means the function is essentially returning nothing. So void push int of item. So that as I said, having a good understanding of C will help understand the program better. Now this is a return type. This is the function name, and what you see inside the parenthesis is the set of parameters. This is the data type and this is the variable itself. So What we are essentially doing here is we are creating a function called push with the variable or with the parameter item. And as we enter the function, first we check if the top is equal to max minus 1. What that means. So in C or in for that matter in computer science, we know that the starting location is normally 0. So having that understanding would help us understand that this is 0, this could be 1, 2, 3, and 4. Now, as I said, in this case, max is equals to 5. That is, the maximum size of the stack is 5, and max minus 1 would be 4. So as I said, this would be 0, 1, 2, 3, and 4. So what this essentially is checking is if the top is already at the highest position or the last position in the stack, that means the stack cannot have anything more, or it uh, cannot accept a new item coming into the stack. So what we are doing here is we are printing that stack overflow is occurring and we are returning. So where does this return go? So as you would know, if you have understood functions, return is a variable that indicates that we are returning the control uh, to the called function. So if whenever this function is called from a different function, and when the control sees return, the control is returned to the called function. From wherever the function is called, it is returned to that location back. Now, if this condition is not satisfying, or if this condition doesn't occur, so the control would automatically come out of the if structure, and it would increment the value of top. Now, we have initialized top to be minus 1. I said we will understand why it is minus 1 later. So top is initialized to minus 1. Assume that minus 1 is somewhere here, and when we increment top to 1, so what we are essentially doing is incrementing top by 1. So minus 1 would become 0, and a of top is, if we are considering this as the array, and you call this array a of top is now a of 0, which is this location, and whatever is the item that has been sent by the calling function, that item would be inserted to the location in the array. In C programming language, or for in that case in most programming languages, we know that this is an assignment operator. So one has to really understand that whatever is on the right side will be assigned to the variable on the left, or to the location on the left. So item is inserted to a of top, and top is uh, calculated here in the previous step. It would be minus 1 initially, and minus 1 would become 0. A of 0 will be inserted with the first item. A of top is equals to item. So this is push function. And as top increments, it could go to 0, it could go to 1, it could go to 2. As top increments, the items of the stack are populated automatically. We have understood the push function. Now, int pop. So the return type of pop here is int. That means whenever this function is called, and when the function has completed execution, or whenever it encounters a return statement, it should essentially return an integer value. So that is the understanding. So when there is void, there is nothing to return. When there is int, it returns an integer type of data, or integer type of variable. Having this understanding is equally important than just memorizing the program. It could help in your Viva. It could help in any situation where you'll have to explain the code itself rather than just writing the code. So int pop is a function where the return type is int, and pop is not taking any parameters as its input. So when int pop function is called, we are first checking the location of top in the array or in the stack. So if top is equals to minus 1, so what does that mean? If top is already at minus 1, there is nothing to remove. So when the stack is empty, you cannot remove an item, or you cannot pop an item from the stack. So when that condition is occurring, or it is satisfying, we print the statement that stack is underflowing, or stack underflow has occurred, and we return minus 1 to the calling function. We will see where this function is returning, and how minus 1 is processed later, but as we are just going from top to the bottom, we're just understanding the program line by line. So if this condition doesn't occur, we can definitely remove an element from the stack. How do we do that? Int item is equals to a of top. So wherever the top is currently, for example, you've inserted just one element, and say that one element is here at location 0, and assume that the value of that element is 1. What this line of code would do is it would assign the value at a of top into the variable item, and it would decrement the value of top. That means we have copied, or we have assigned the value present in the top location to a variable called item, and we are decrementing the top by -1. Or else, in other words, once we have removed it, we are decrementing the location by 1. So that is what is happening here. And once the item is copied, that item has to be returned back to the calling function. As I said again, as I said before, we will understand where this function is returning and how it is processed later. The next function, void display. Void is again a return type, and it is not returning anything. And you could see that there is a return statement, but actually nothing is returned. That is, here you would see that an integer -1 is returned. Here just return is there. That means it is returning the control, but not returning anything with the control. That is the understanding. Display the function name. So we are creating a variable called int I. Why do we do that? When we are processing the array, or there is a concept in C called traversal. So when we are traversing the array, or when we are traversing the stack, we need a temporary variable, and we will be using that variable to print the current element. So before we actually print, we will first check if the stack is empty. How do we do that? If top is equals to -1, if top is already here, that means there is nothing in the stack. So we just print stack is empty, and we return the control. If this condition is not occurring, we are printing all the elements in the stack. Stack elements are, we just print this line, and we create a for loop. So for loop executes until the condition fails. So starting with I is equals to top. So wherever the top is currently, for example, if your top is here, that means the value of top would be 0, 1, 2, 3, and 4. Value of top would be 4. So I would be initialized to 4, and until and unless I is greater than 0. As long as I is greater than 0, the for loop executes, and every time the for loop is executed and the control is back to the for loop condition, I is decremented by -1. Why do we do that? So if we start from here, we print the first element, and the next time when the for loop executes, we want the for loop to print the next element in the stack, and in the next iteration the next element, and so on and so forth. So that is the understanding. For I is equals to top, I greater than equals to 0, I minus minus, printf percentage %d. So this is the type of data. Here it is a digit, and we are printing a of I. So as I said, we have assigned the value of top to I. So we are referring a of I. That is, if this is top currently, we are actually referring to a of top, or the current location of top, but we are calling it by the name I because we have assigned the value of top to I. Why do we do that? We don't want to change the value of top. We want the value of top to be constant, but I could change because I is a temporary variable which has a scope only within the function. So until and unless I is greater than equal to 0. So once I is equals to 0, we have essentially printed all the elements in the stack, and in the next iteration I is decremented by 1. That means the value of I would be -1, and that would essentially mean that there's nothing more to print. So once that condition is executed, the for loop is completed, the control comes out of the for loop, and we're just printing a new line. So this function would display all the elements of the stack. Okay. The next function in the program is palindrome. The C behind the word palindrome is just to indicate we are checking whether the number is palindrome or not. This again is not returning anything. It is the return type of this function is void. We are creating two temporary variables called flag and I. Uh, Moving ahead in all your programming language laboratories and for various other applications, flag is a very commonly used variable. You create the variable called flag to check a condition. For example, now when I say condition, in most of the applications, the condition would be the result of the condition would be yes or no. In other words, 1 or 0. So you would create a variable by name flag of the type integer, and you would assign it 1 or 0 depending on the case. So this is something that you have to keep in mind. Flag is a very commonly used variable name. And having a background of C would kind of assure you that the variable could be anything. It need not be flag all the time, but this is the commonly used name. I is again a temporary variable. So when we are checking when we are checking if the number is palindrome or not, when do we say a number is palindrome or not? When read from the front to the end, or when read from end to the front, that means from left to right or from right to left, the number should essentially read the same. For example, 1, 2, 1. If you read it from the left to right, it is 1 to 1. If you read it from right to left, it is 1 to 1 again. And such a number is called palindrome. Any other number, for example, 1, 2, 3, is not a palindrome, because 1, 2, 3 read from the left is 1, 2, 3, whereas read from the right is 3, 2, 1. So it is not a palindrome. That is the understanding. Now, you first print the contents of the stack just to make it more understandable. So we just print the elements of the stack. We have already understood this logic, where we start from the top and we decrement every time by -1 as long as I is greater than or equal to 0. So we print the value present in the stack. Once we have printed the elements of the stack in the top to bottom order, now we are printing in the reverse order. Essentially, when we are reading it from left to right or from right to left, the same is implemented here from top to bottom or bottom to top. When we are printing from the reverse, obviously you would have to change this condition in the exact opposite. So you would start from 0, I is equals to 0, and every time you would increment by 1. So it would start from 0, it would go to 1, it would go to 2, and so on and so forth, as long as or until and unless I is smaller than or equals to top. That means the for loop has to stop when the value of I becomes equal to the top itself, and it shouldn't go further. So that is the condition, and as long as that condition is occurring or it is satisfying, we are printing the contents of the stack. We are printing each element individually. Now we have just printed the stack contents from top to bottom and bottom to top, that is normal order and the reverse order, but we haven't yet checked if the number is palindrome or not. The logic here is a fairly simple logic. It would probably be used in so many other programs as well. And one very important disclaimer: any program in any programming language could be implemented in multiple ways, and it solely depends on the programmer or the person who is developing the logic. And the logic could be simple in one case, it could be complex in the other. So it is the disclaimer is this is not the only way of implementing this program. There are various other ways. So in this logic, how are we checking if the number is palindrome or not? So again, we are traversing the array itself, or we are traversing the stack. We are starting from 0, that is we are starting from the bottom, and we are going up to top by 2. Now in computer logic, when you just say top by 2, and suppose top is an odd number, for example top is 5, 5 by 2 wouldn't be 2.5, it would just be the whole number, it would be 2. So starting from 0, it would go from 0, 1, and 2, and every time it is incremented. So that is the logic. So what we are actually doing is, if suppose there are 6 elements, or there are for ease of understanding, assume there are 6 elements here: 1, 2, 3, 4, 5, 6. So what you can do when checking if the number is palindrome or not is start from here. This is the firstmost digit or the leftmost digit. You're comparing this with the other end of the digit. I mean, other end of the number. For example, this is the left end. This would be the right end. Or if this is the bottom end, this would be the top end. So the logic here, or the idea behind this line of code is, we are comparing the first number to the last number, the second number to the last but one number, the third with the other, and so on and so forth. So that is the logic. So when we are doing that, we just can go up to the half of the number of elements. For example, there are three. I mean, for example, there are 6. We could just go till 6, because when we have checked the first number, we have also checked the last. When we have checked the second, we have checked the last but one. When we have checked the third, we have checked uh, the last but second as well. So that is the logic. So that is why you would see I is equals to top by 2. There are other ways as well, but this is a choice made because in most of the cases you would be asked, or the requirement would be to run the program in the shortest time possible. So this is one of the optimal methods that you could use. So you would just check up to half of the contents of the stack, and so that is the logic. So that essentially is the logic behind this for statement. And every time in the for loop, as I said, I've already explained the logic. and we'll just see how it is implemented in code. A of I, suppose we are starting from 0, A of I would be 0, is not equals to. If this number is not equals to A of top minus I, suppose this is 0, now top is, just say for example, it is 4. So this is 0, 4 minus 0 is 4. So we are checking this number with this number. If it is not the same, if it is not equal, then we are changing the value of flag. As I said, flag is a variable that you would use to check a condition. So you have initially assigned it to 1, but if it is not equal, if the leftmost digit is not equal to the rightmost digit, we are changing the value of flag to 0. That means it is not a palindrome. And once the condition is failed, you can just stop it. For example, there is 1, 2, 3, 2, 1. You just have to check all the digits. But once you see that the digits are not matching, for example, if the first digit is not equal to the last digit, there is no point in continuing or checking the other digits. So once you would encounter this condition, you would essentially break from this for loop itself. So you'll come out of the for loop and you'll print a relevant statement. So that is the understanding here. But if it is equals to, that is, if the leftmost or the bottommost number is equals to the topmost number, uh, then this condition wouldn't be satisfied and flag wouldn't be changed. Flag would remain 1. So that is the understanding. So this whole for loop, runs or executes for these many number of times. We have understood why it is so. And once the for loop is executed, the control comes out of the for loop and the value of flag is checked. It was 1 before. If anywhere the condition has failed, the flag would have changed. If it does not change, we can clearly tell or confidently tell it is a palindrome. And if we are going to the else part, when the flag is not equals to 1, we can confidently tell it is not a palindrome. So that is the whole understanding behind C palindrome function. We have understood all the functions in the program. Now coming to the main function. So in C programming, it is its main function where the execution starts. When we'll execute the program, we'll understand, or I'll go through the order of execution. But just have in mind that in a C program, the execution starts with the main function and not with other functions. So void main is the function, and we are creating two variables called choice and item. And this is a menu driven program, and menu will obviously require a choice. So hence the name choice, and item we will see why it is used for. Now for colon colon, I mean for semicolon semicolon. So this is a very popular way of implementing infinite loop. So this could be a very common Viva question, or like it could be asked anywhere. So is this the only way? It is not the only way. We can create another way. For example, while of one. So while is another a programming construct where it is the control keeps on running, or the execution keeps on happening until the condition is true. Now we are not using that method. We are using the method where we just type for semicolon semicolon. That is, there is no condition specified. That means whatever is there inside the for loop runs infinitely. For example, if you just type inside the for loop, if you just type print 1 in the execution, it just keeps on printing 1 until the system reaches an error, or the CPU cycles hit to a certain value. Now that's the understanding. So we are creating a for loop that is which is an infinite loop, and once we enter the for loop, we will first print this is the menu, and we will give the menu options. Uh, Printf, press 1 for push, 2 for pop, 3 for display, 4 for palindrome, or I mean check palindrome, and 5 for exit. Because we have created a infinite loop, there should be some way to exit out of the loop. So we are creating this choice 5, and when the user enters 5, the control comes out of this infinite for loop. Every time the for loop is run, we have to ask for the choice. So printf, enter your choice, and the choice entered would be stored in this variable called choice. Now switch is a programming construct which is used to check against multiple conditions. So having choice as a variable, it would compare with these case values. So if choice is equals to 1, this block of code would be executed. If it is 2, this block of code is executed, and so on and so forth. So that is the understanding of switch. Switch choice case 1. So when the value of choice is equals to 1, that is when the user has entered the choice as 1, that means he has asked, or he or she has asked us to push an element into the stack. So we take the input printf, enter the item to be inserted, Scanf, that is, we take the item and store it in the variable called item, and we call this function. I was explaining about calling and called function. So here we are calling the function push of item, and we are passing the variable or the parameter called item. So this main would be the called function, would be the calling function, and this would be the called function. So this function is called by this function. That is understanding. And when it goes, I mean, when the control goes to the push function, the set of lines inside the push function is executed, and the return, when the control is returned back to the calling function, that is main, it would come back here again, and that particular case would, or that particular iteration would break, and it would go to the for loop again. That is the understanding here. When the choice is 2, when the user wants to pop an element, we don't have to take an input, so we just call this function called pop, and pop will return an item. I have explained before that pop is returning a variable or data of type integer. It is returning item, so that is stored in item. And if it is not equals to -1, that is, when we have seen here in the pop function, if there is nothing in the stack or the stack underflow condition has occurred, we are returning -1. This is for our reference. You could return anything else. For example, you could return 999 and make sure that if it is not 999, you would print it, because that is our way or our understanding that the stack is empty. So we will check if item is not equals to -1, we will print what is the item. And if it is -1, this line wouldn't be executed. That is very clear. So if item is not equals to -1, we will print the item, and this is the way of printing it. And basically, it is a digit, and item, comes and takes this position of %d. And once this case 2 is executed, it is the iteration is break is it executes, or it encounters the break statement, and comes to the for loop again. If the choice is 3, that is, if the user wants us to display the contents of the stack, we just call the function display. So display is called here. The control goes to display, it executes a set of lines, and it comes back, and it encounters break. When the choice is 4, palindrome is checked, that is, if the number entered in the form of the stack, if it is a palindrome or not. And we are using break again, as the same explanation goes for as I've explained for the others. And when the choice is 5, that is when we have for various reasons, when we have to exit the for loop, we have, for example, when we have demonstrated all the other functions, we just want to come out of the loop. So when the choice is 5, we are just calling the inbuilt function exit. um, and when exit is encountered, the whole execution stops. So basically the whole program would have complete execution, and it would come out of the control itself. So that is the understanding of the program. Now let us see how the program works. Now, in most educational institutions, Linux is the operating system that is recommended to run these programs. So we are currently seeing the terminal where programs would normally be executed. The method of execution should be understood before that, or else that would lead to unnecessary problems. Now, uh, in order to execute a C program, we would require a compiler. In this case, we are using a global compiler, GCC. That is the way we call the compiler. And we need to first compile the program. So GCC p3.c. p3.c is the name of the program. And when we are using the compiler, global compiler, and we are compiling the function. Now, we have once we enter this line of code, or once we enter this command, we click enter, and if the control comes back with this, if you don't see any message, that means that there are no errors in the program. But that may not be the case. Normally, any typing error or any programmatical error would result in a set of errors that you could encounter. For example, a very common error that you would see is that you would have missed entering the semicolon. So I've just made an error intentionally. Let us now execute the program again. We will see what happens. GCC p3.c. You see there is an error now. And one very important note or a caution to all the students is, when you see an error, it is an opportunity for you to go back to the program, analyze where the error has occurred, and correct it. having an error is not a problem, not resolving the error is the problem. So you would clearly see what is the error, and you, in any interface or any IDE that you would be using, you would see some message which denotes where the error is. For example, it says it is expecting a semicolon before for. So and it is clearly indicating the line numbers as well. So before line number 53, that is where we have for, it is expecting a semicolon. So we have not entered a semicolon here. We know we had made that mistake intentionally. Now we are coming back to the program. We have corrected the error. Now let us execute the program again. GCC p3.c. So now we have resolved the error, and hence you wouldn't see any error. So when you compile the program, if you don't see an error, that is a green flag. That means there are no errors, and an output file, an .o file would be created in the directory. And how do you execute, or how do you get the output? This is this is the command that you would have to enter. /a /a out. So this is the line of code that you would have, or the command that you would have to execute or enter in order to get the output. Basically, when you compile a program, a file called a.out would be created in this directory, and you're executing the, or you're entering the file. That is a good understanding to have. So as I said, now let us, as we execute the program, I will give a very brief understanding, or very brief run through of the program, how the control actually goes, and we'll understand the program better. So now the once we have executed the program, it has entered the main function, and it is in the infinite for loop, and it is printing this line of code, enter your choice. So it is waiting currently for us to enter the choice. We enter 1. That means we are interested to push an element into the stack. It is asking what is the item to be pushed. For simplicity, let us consider it to be 1. Now the item 1 is now inserted into the stack. It is again, in this case, 1 would execute. It would So when the choice is 1, case 1 would execute, and it asks us to enter the input. We have entered the input, and it calls the function push. So behind the scenes, it would go and call the function push. These lines of code would be executed, and it would return back. So that is what happens behind the scenes. And once it goes back, and in the second iteration of the for loop, it again prints the set of line and asks for the choice, or asks for the input. So again, we are interested to push, and enter the item to be inserted. Let us now maybe enter 2. It again carries out the same thing. Now let us again push an item. For example, now let us enter 3. So that the behind the scenes, the same explanation of the same you know the same method of execution happens behind the scenes. So we have entered 3 numbers, 1, 2, 3. We'll push a few more elements. We can push 2 more elements because the max is 5 in our case. So now let us enter 2, and in the last iteration, let us enter 1 again. You would understand why I have chosen such numbers. So now we have entered 5 elements that are into the stack. Now we are interested to see what are the elements of the stack, and for that we'll have to enter 3. See, there it is. We see that the elements of the stack are 1, 2, 3, 2, 1. Now this is a palindrome itself. We know that. Let us check if the program is able to detect that, or understand, or identify if it is a palindrome or not. How do we do that? We enter 4 to see how the palindrome function works. So in this case, um, we have entered the choice as 4, and so hence C palindrome function is called. That means the control would go here, and all the set of lines would be executed. So it would first print what are the stack elements, 1, 2, 3, 2, 1. When you go in the reverse as well, so considering this is left hand, this is right hand, even from the right hand, if you read, it is 1, 2, 3, 2, 1 again, and hence it is a palindrome. It's very simple. Now we have now demonstrated 1, 3, and 4. Let us now try popping an element. So when I press 2, it is essentially popping the topmost element. So it is removing 1 now. If I do it once more, it would say the element popped is 2. Now you will be asked to demonstrate stack overflow, stack underflow as well. Let us see that as well. Now let us see. Okay, now we see that the elements of the stack are 3 to 1. Let us push 2 more elements. For example, let us push 4, and let us push 5. So let us see what are the contents now. So the contents of the stack are 5, 4, 3, 2, 1. If I try to enter another element, uh, if I try to enter another element, let's say it is 7, you know what it says? It says stack overflow because the maximum capacity of the stack we have created is 5 here. And we could do it any number of times and the message would simply repeat. It simply says stack overflow. Now we can just keep on, popping the elements of the stack. Let us do that. It is popping the elements from this order. 5 is popped, 4 is popped, 3, 2, 1, and so on. So let us do it 3 more times. So you would see that all the elements are now popped. That is, the last element was 1. If I try to pop again, so the expected output should be that it should display it as an underflow condition is occurring, and we see that stack underflow has occurred. So in this program, we have understood the basic implementation of stack functions. We have understood this function called check palindrome. We have analyzed the output. Now let us end the program gracefully by pressing 5, and this would exit the execution itself. So we see this familiar view where it is again waiting for us to enter a new command. So we have executed all the possible um, methods or all the possible cases of the function, and we have clearly understood the functioning of stack. Thank you.